All right, what's on the plan today? Schedules. Yeah, well, obviously we're talking about the schedule, right? Oh, no. Sorry, schedules in our controllers. Okay. We're going to talk about dashboards and graphics. And we're going to talk about dashboards versus graphics because they're the same thing, but they're different. Exactly. Exactly. Okay. And really, graphics, no, I'll save that. Never mind. We'll keep pushing forward. We're going to hear from Joe at Contemporary Controls. He has a presentation for us right after our morning break. We're going to have lunch and lesson plans again. I believe on the menu today is Rob and Justin. Sorry, menu is the wrong word. Menu should be what's for food. They're the ones presenting today. Okay. I don't know what's on the menu. We'll find out when it gets here. Larry knows. Larry disappeared. Okay. After lunch, we're going to start looking at programming at a supervisory level. Okay. We have talked about programming controllers before again and again and again, and I'm sure it's something you work with your students. Programming at the supervisory level is a little different. It's got a whole different series of tasks. Programming at the supervisory level is where we start to really activate system-level thinking and implement system-level thinking. Okay? So our whole building works together instead of as a whole stack of individual pieces. Okay? We have a dinner presentation, or dinner and a presentation here tonight. Again, I don't know what we're eating, but Sean will be presenting for us. For anybody who's talked to him, I'm sure you are probably really excited to hear what his presentation is, the meat of it, because I'm excited. I'll put it that way. Okay. Last thing on the bottom here, building access. Okay. You've all been wandering around the building all this week so far. Keep it up. If you've got questions, if you need access to someplace, let me know. I'm going to switch over because I can do that. Okay. This is a quick map of the first floor. Okay. We are here. If you come out into this main hallway, we see all these construction labs. If you want to go wander through those and haven't already found the route to get there, come out here to our commons through this first door. This garage door right here is open, as are the others. Feel free to go in and wander through. Over here in the HVAC labs, for those of you who haven't been physically in the building before, because I forget how long it's been since people have actually been here, I have opened up our HVAC labs so that you can get into those as well. The garage door here into our refrigeration labs is open. The door to the controls lab, which is off the main hallway right across from the restrooms, and the door to our commercial lab here from the main hallway is open. You can get to the residential lab. There's a door right at the back corner of the commercial lab. It's not locked. I don't even think it can lock. And you can just walk on through. Feel free to wander. Okay? Our sheet metal lab, shop practices lab, if you've seen a sheet metal lab, you know exactly what's there. We don't have anything wild and crazy going on there to show off. I was hoping to have our CNC pen plotter up and running by then, but yeah. You can see its base sitting at the back of the controls lab if you want to look at that. It's kind of been an interesting project that's taken way too long. Okay? But that's first floor. Right now, second floor, everything's locked up. That is electrical and plumbing. If you want to go up there and take a look at things, Lanny has specifically requested some quick tour access up there, and we're planning on doing that over the afternoon break. Okay? If anybody wants to go up there and see things, how we're doing it in our electrical, how we're doing it in plumbing right now, you're welcome to join us. Planning.
How many tokens does it take to be able to ride the cat simulator? Tractor simulator.
You guys got one of those virtual cat driving classes?
Mm-hmm. The only one in the state.
Yeah, I saw them at NASA.
Mm-hmm. So I'll see if somebody really wants to. It is a fun. I mean, it's a freaking arcade game, man. What can I say? If somebody really wants to, I will talk to our coordinator for that and see if we can fire it up today. I think he's in. Okay. Pete.
Robert, how long has the program been here? I know that you went through kind of a transition and you've got such a beautiful space.
So this building has been actually complete for literally about a month under 5 years at this point. We opened our doors fall of 2017, 18, 17 for classes. So we're about to hit our 5-year mark of actively teaching in this building. The individual programs have been around significantly longer, but with the exception of literally all of the programs that are in this building moved to this building when it opened. We moved HVAC from the west end of town, literally about 45 minutes from here. Same with our architectural drafting and civil engineering. We moved plumbing, electrical, and construction from the south campus, which is about 10, 15 minutes that way, literally that way, straight south. And we also have welding in this building. Our main welding is still down at the south campus. And then we pulled in our masonry program from our applied technology campus, which is a little bit further north and west of here.
Were all the programs involved in the design of this building?
Funny story. All of them but HVAC. When we moved into when we were planning to move into this building, it was a full changing of the guard for the HVAC program. The existing instructors had absolutely no intention of moving, so the college said, okay, that's fine. We will get new instructors. Those instructors also decided, since they weren't coming here, they weren't going to apply any effort into helping us plan this building. And they were more than happy to tell us on what should move from the existing facility to here, which was literally everything they had, which unfortunately looked more like a scrapyard than an HVAC lab.
It's interesting because, I mean, somebody's going to have to get credit because I think they did a wonderful job of allocating some great space for you guys to build out and design. That typically doesn't happen when a program isn't involved in the design process.
Yeah, they blocked out the spacing for us fairly early on in the planning process. The real challenge came once the physicality of the building was there and it became, okay, what do we need to put in the labs? They had the basic infrastructure there from an electrical standpoint. We kind of missed the whole concept of floor drains in 2 out of 3 labs that should have had them. We kind of missed that one, but you know, that's how it goes. So, okay.
Do you still have those tool vending machines?
No, I wish we did, because I would like to still be able to send students to it. That was, I believe that idea was abandoned by Fastenal. It wasn't our choice. So we had a tool vending machine that was just like the vending machines out here, except you could get a pair of pliers and safety glasses and gloves. And it was provided to us by Fastenal. And they were the ones who stocked it. They were the ones who profited off of it. And, you know, it worked about half the time. I think they had about 10 of them spread out around the country, and about 3 of them could actually accept a credit card. Everything else was corporate checkout type stuff. So the credit card functionality didn't seem to be working. I think Fastenal has since abandoned that whole concept, which, again, is kind of inconvenient.
I see that plywood machine work really well in the manufacturing board
Mm-hmm. Yep.
and any type of tool.
Yes.
It's on the track, it's disappeared.
Yep. Yeah, it's been implemented all over, and like Bob said, especially in manufacturing facilities, to huge effect. Helps you track which person is burning up all your drill bits and needs to be taught, go back to classes on how to use a drill. But, so, yeah, again, I really wish it had continued, but that's how it
Robert,
goes.
Is it here that centralized tool crib?
Yes,
It's here?
yes.
And serves all the programs,
Yes, it does.
which is really a nice feature.
Back to the map. This is our shared storage area. Back here, this is the tool crib that Peter is talking about. It really works as literally the supply house. It also works as the company tool crib. So students have to, like for our construction program, they honestly probably do the best at utilizing it out of all of us, because they'll send their students back there. They'll give them a project, make them plan out what they need from a materials and a tools standpoint, and they'll send them back there to check out the materials and the tools. The materials aren't pre-set up. It's literally like going to the lumber yard and getting what you need. And if they have to go back a second time to get more materials, or if they have an excess of materials left over, they gig them on the grades for it, because they're not being effective with what they need to do. Okay? They also, like I said, check tools out that they need. They check out anything basically that their students don't have in their tool bucket. Okay, so if it's a company provided tool, they have to go check it out. We've adjusted that a little bit for HVAC. We put the tools back there that you would have to check out from the company. Okay, so we're talking like core drill, the big hammer drill, stuff like that. We take it that if you would have it on your tool truck, on your service van, then it's going to be in our storeroom and you go grab it. Because in our trade, that's how it would go. So, but it is back there. Depending on whether the guys are there or not, the garage doors will be open or closed. But feel free to go and peek through the windows at least if you want. That has been a very successful adventure for this building. All right. Questions on what we're going to do today? Comments? Concerns? Sound good? Let's do it. Schedules. We all know what a schedule is, right? It's when you go to work. It's when you go home. Right? It's the occupied schedule for this building. Right? That's all a schedule is. Is it? Is that what a schedule is? Russell's back here shaking his head no. What's a schedule, Russell?
Be anything to bring you on occupancy or an occupancy of your building. It can be when your equipment starts up for the day, get down to temperature where it's at. Schedules can be about anything you want.
Ah, I love that statement. Schedules can be about anything that you want. Okay? Do not limit yourself on what a schedule is capable of. Okay? A schedule is a timetable, okay, where we can select what's going on. Maybe it's a schedule that's set up just for a 24-hour clock. Every 24 hours, the schedule repeats again and again and again. Maybe it's a weekly schedule. We do certain things Monday through Friday and different things on Saturday and Sunday. Maybe it's a monthly schedule. You know, November, we have to deal with Thanksgiving, right? Thursday and Friday, or maybe just Thursday for your company. See? So those types of things are all components of a schedule. But as far as what the schedule can actually do for you, sky's the limit. Startup sequences, optimize start, stop. Big building, especially buildings that use a lot of like water source heat pumps, really big in our school systems around here. You don't want all of those trying to start at exactly the same time when the occupancy of the building starts, right? You want to offset it a little bit so you don't shoot your peak load right through the roof, right? Schedules will help you do that. Okay? You can use a schedule to determine the digital value of occupied versus unoccupied for a building. You can use a schedule to set an occupied versus unoccupied set point directly. Okay? What you can do with a schedule is really only limited by what you can think of and what supporting tools your system provides you. Okay? The schedules that in the BAS View 3 are pretty basic. Okay? But that really, it doesn't limit them because the supporting tools that we have really boost us. And that's very frequently the case with control systems. The schedule itself likes to turn things on and turn things off. But when you take that information and put it into a virtual point, then you can take that and go wherever you want. Use calculations, use programs. Again, your imagination is the real limit. Okay? Yep. Is that it on schedule? Rob?
Could you describe that as actions associated with time? Is time always something that happens? So schedules are time only, or are they? Others are events.
I'm going to say, and this is definitely up for debate, so please, if you disagree, please say so. I would say yes, a schedule always has a time component, okay? It may not be a direct time of day. It may be a change every 4 hours sort of thing. But from my perspective, events like, and I'm not talking like a conference, I'm talking like somebody pushes the override button on that thermostat in the middle of the night. That to me is not the function of a schedule, that is a programming function.
It's an event.
Yeah. So, you like that?
Yep.
Do you not like that? Like I said, feel free to disagree with anything I say ever. Come on, let's talk about it. I like it. But yeah, that really is it for schedules. Schedules themselves, pretty straightforward and simple. Other questions? Peter?
So when the building is turned over, new construction, the schedule is going to be an estimated version of what it should look like, I suppose. And, so
how do you begin to optimize the schedule after everybody leaves at the, on the operational side? I think that's where the challenge is. Do you have to call in a Paul Ehrlich to
That-
run analysis or
That's a really fantastic point and question, Peter.
That's workshop topic.
The real benefit to schedules, or the crucial thing with schedules, is they have to be set up accurately for what you need them to do. Things like the occupancy schedule for a building is really one of the easier ones in theory. Okay? From my perspective, the schedules should be more than an estimate when the building is turned over from construction to operation. And most of the time, that's really surprisingly practical, because as the controls technician, you are one of the last people out of the building. I mean, you might, some people will come in for spot fixes after you officially leave, but really, you and maybe some of the guys dropping the last couple of tiles or doing fire alarm testing, you're literally the last handful of people. So if they don't have the people who are going to be occupying and managing the building in place before you leave, that's really kind of uncommon. So that conversation of getting the schedule set up right in the first place should happen at that time. If it doesn't, we're often also sent back for owner training towards the beginning of the operational phase of the building, and that can definitely be a conversation that happens then. So, past that, with actually figuring out what the occupancy schedule for your building needs to be and related scheduling, as Robin said, that's a whole topic. So, it's a good question. Does not have a simple answer. Other questions? We're going to run through the presentation on the programming side. We'll come back after our break and re-reference a couple of things, just a real quick touch, and we'll get into practicing. Okay? Or maybe I've got graphics next? Nope, I got programming. Okay. I don't think I made slides on graphics. That's interesting. Anyway, told you it was a long week. Programming. Programming, like I said before, we've done programming for controllers before in these workshops. But the head-end programming, the supervisory level programming, is where we bring the individual pieces and make them a functional system. Okay? It is fairly important that we give the controller programming enough attention that it can focus or function relatively okay autonomously. So if your network goes down, if your supervisory controller blows up and jumps off the wall, the rest of your system does still need to function, right? If your whole system relies on this one box, that's scary. And I'm not saying we didn't used to do that. Going back to the days of pneumatics, if your compressor died, it was a bad day. Okay? And in our early DDC systems, we didn't have all the distributed controllers we do now. You would have had a couple of big panels throughout the building that controlled everything. And you can still run into those legacy type systems that still exist today. It was only 8 years ago or so that we tore the last of those type of panels out of our own college. Had to do a controls retrofit on an entire building because 3/4 of it was literally controlled by 2 panels. And yes, that was just as ugly as you would think it would be. Okay? So the head-end programming is really what brings it all together, really finishes it off from a functionality standpoint. Okay? There are a handful of things that a head-end program has to accomplish, or typically accomplishes. Sorry, I shouldn't say has to. Data transfer between controllers. Okay? If we have air handler 1 and the 20 VAV boxes under it, it is typically applied as the task of the head-end controller, supervisory controller, to tell all of them when their occupancy schedule is. Okay? It is common to only have 1 or 2 outside air temperature measurements on a building. Okay? Well, your air handlers need to know that for economizer. Your boilers need to know that for reset. Your chillers need to know that for when they're going to turn on. Are those all on the same controller? Boy, I hope not. So, we have to transfer that, find where that point is, and make sure everybody who needs to know outside air temperature knows the outside air temperature. Okay? And I'm not saying there aren't systems that exist out there that do put an outside air temperature on every controller that needs to know outside air. And there are definitely some positive and negative arguments that you can make about that idea. Okay? I don't want to debate that one. That's a good topic for discussion, though, with your students. That can be a lot of fun. Okay? Doing things like lead lag control. Okay? Who's familiar with the term lead lag first? I want to make sure everybody's okay. Okay. So we don't usually apply that down in the controller level. We deal with the failure portion of it at the controller level, but oftentimes we want a higher level control because we need to be able to manipulate that a little bit. Okay? Again, this could be another spot where a schedule is useful. I want to change over between pump 1 and pump 2 every 12 hours, or every 24 hours, or every 145 hours, whatever it happens to be. Okay?
Is that primarily because you don't always have that time date function at the local level?
Correct. You either don't have that time date or you don't trust that time date. Okay? That's actually a topic I don't think we've ever covered, Ted. I'm going to come back to it here in a second. Brad.
Are you talking about creating your lead lag logic inside the supervisory controller, or using the supervisory controller to tell your logic at the controller level? Because I like to put my logic in the controller level.
That would be a much better way to phrase it. You're right, Brad. You use the supervisory controller to trigger the changeover that exists within the controller. Thank you very much. Yes. And back to Ted's question about we don't always trust our small controllers to either know the time or have an accurate time. And this is something that's really manufacturer dependent. Some controllers have what's called a real-time clock chip. And this is literally a clock on the controller. It's a dedicated chip that its one and only job is to keep track of time. Okay? You have one, if you've got a watch, you've got a real-time clock chip in your watch. Okay? Or a conglomeration of things that give you that function. Okay? Traditionally, control systems did not want to spend the money. And when I say spend the money, I mean like 3 frickin' cents for a real-time clock chip to put a real-time clock in every controller. Okay? So they didn't have the time. Or they kind of fudged it and let the main processing chip in the controller calculate the time as well. Okay? And sometimes that works okay, and sometimes it works like Andover did it, and it worked really, really poorly. Because the more programming you put into the controller, the more time you lost. Okay? So that's one of those things. One of the crucial things with a supervisory controller is that the time is accurate. Most companies have different ways, though we've kind of settled on mostly a standard for that, for keeping track of the time in our supervisory controllers. Okay, and that's using the network time protocol. So it basically goes out to a server on your network, or a server by Microsoft, or the US government, or any dozen of other governments that have time that's kept by things like atomic clocks. Right.
Just a quick question, does BACnet have a time object? It seems like that might be a way to standardize about that, so that they didn't have to.
That's a good
because
question.
Standardization isn't necessarily be all and end all for controls companies, is it?
Standard, you are correct. Step one is acknowledging that standardization is not necessarily the winner for control companies. But let me switch over here because I mentioned this before, that there are 60 objects. So this is just the Wikipedia entry for BACnet, and it is quite accurate. So here is the list of all of the BACnet objects currently supported by BACnet. And if we look, time value is one of them. Okay. We also have over here, I think, a date time value, those kind of things. So yes.
So you can standardize if you had one controller going out, getting the time and putting it into a BACnet object, then it would be accessible by all your controllers, theoretically.
Theoretically, yes.
Life is good and the sun's in the right position.
that is an accurate statement. But yes, because we do have these date time and time values present within BACnet, we could utilize them for something like time synchronization. But again, that relies on the manufacturer deciding to utilize that capability. And the truth is, because of us relying mostly on our supervisory controllers to maintain our schedules, I really don't often care what time this VAV controller thinks it is, because it's getting all of its major time-based cues out of the supervisor. So, yes, it's possible. Could we do it? And could we benefit from it? Yes. Do I foresee it happening? Not really. Well, yeah. Yeah. I think we'll leave it at that. Okay. But again, this is just the Wikipedia article. If you are curious about, just a quick high-level skimming of BACnet and the list of BACnet objects in a document written at less than a doctoral level, the Wikipedia article is really handy for that. And like I said, realistically, we probably use about 15, maybe 20 of these 60 objects on a regular basis in most systems. And the other 40, you really kind of look at when it shows up and go, I didn't think anybody actually did that part. Because again, Just because a device is tested for support of using a particular object does not mean the manufacturer is interested in actually using. Okay. Another thing we like to do, or sometimes like to do, in our supervisory controllers is global reset schedules. I'm using the word schedule here because that's normally how we put that together. I've got it as just global resets on the slide so that we're not confusing this type of reset schedule with a schedule. When I say a reset schedule, I'm talking about things like changing your boilers, or your hot water system's supply temperature based off of outside air temperature or building load. Okay? Traditionally, we used to do a lot of resets based off of just outside air temperature. Okay? Which, hey, it's better than just a fixed set point. I mean, let's face it. When it's 100 degrees out, you don't need to run your boilers at 180 degrees. Okay? You don't need that much heat generation. So, we turn it down where we can. That was, using outside air temperature for that was the standard 20 years ago. We have since changed in a lot of situations to going off of the load in the building. Okay? And that's why a lot of these reset schedules have moved from strictly a controller level up into the supervisor. Because when you're trying to reset your boiler, a lot of the newer engineering sequences say you're actually going to look at the hot water position valve of every hot water valve in your system, and if more than 5 of them are half open or fully open, then you need to increase your boiler temperature. Or if all of them are closed, let's decrease the boiler temperature, kind of that sort of thinking. And we do that with hot water systems. Nobody's been stupid enough to do it really with chilled water systems for the most part. But air handlers, their supply air temperature and supply duct pressure are very frequently reset anymore. Trim and response kind of thinking. So if you don't need that much pressure, why are you wasting the energy to spin the fan that hard? That sort of thinking. And as we move forward, we're going to get more and more of that happening. So the ability to do those resets becomes much more critical. So that requires a lot of data gathering, some analytical programming based on that data. Are we looking for maximum values, average values, the 5 biggest, whatever you have? Okay? And then we need to pass that value back down to the controller that needs that information. Okay? Data conversions. We did it, looked at converting the data directly on a point yesterday, but that's not always the way we need to do it. Sometimes we need that base value to stay in that point because we need it for some other calculation in that form. Okay? Or maybe we just don't want to do that change at that level and want to change it at another level. Okay? That's one of the things we can do with programming. And doing calculations for data display, trending, or reporting. There is a lot of data that we gather from our control systems, and there's a lot of further data that we derive out of that initial data. Okay? Most of the time, you're not going to get the BTU usage out of a VAV box. We don't do those type of thinking at that level. We usually don't have the information required to do it. So we do it at a higher level. And yes, I understand that weird look, Brad, because no, we don't do that calculation. It's just an example. Okay? Make sense? Before we get into how the BAS View 3 handles these functions, questions, comments? Brad?
You mentioned sharing, globally sharing your outdoor air sensor through your supervisory controller. With BACnet, can't you use the BACnet identifier at the controller level to do peer-to-peer sharing?
So, I'm glad you caught that. That's a great question. So, that depends. So, what Brad is asking is, instead of passing that data all the way up to the supervisor and relying on the supervisor to pass it back down where it needs to go, can we directly share it from one controller to the other controller that needs it? Peer-to-peer sharing. Okay? Some systems support that. Some systems do not support that. Okay? For example, Invensys systems, IA series systems, had a tool that worked with both LAN communication protocol and BACnet to directly support peer-to-peer sharing. So you could make effectively a link between the outside air temperature that you're reading in at your hot water system controller and pass it to your chilled water system controller directly. They just talk to each other. Other systems, like Honeywell spiders, sorry, I'll kick them in the teeth every time I hate spiders, the controller, don't support that. They rely completely on the supervisory controller to do that data transfer. So that's really a function of the system. And where you can do peer-to-peer data sharing, especially with critical values like outside air temperature, you should do so. Okay? You should also document that you're doing so, which is something that we haven't really talked about on all of this. But when you set up systems like this, you should be providing a lot of documentation. Okay? But that peer-to-peer data transfer is one of those really important things that frequently gets missed in documentation, because if another technician comes in and is expecting to see all that data transfer being done through the supervisor, and they don't know to go look at the direct peer-to-peer sharing tools, they won't know that it's happening and can screw things up because of it. Not a voice of experience or anything. I haven't screwed anything up ever in my life. Great question, Brad. Robin?
Just thinking about thinking now about the architecture of the control network. Wondering if we have anything available, if there are software tools available that will go out and map your control networks the way we do with LANs and LANs. Go out and actually find all the devices, identify them, put them in a nice map so that you can look at them.
You can answer that question yourself, Robin. What do you think?
Not a chance.
I will not speak on behalf of like Siemens Corporate, Johnson Corporate. They may actually have locked up in a secret dark dungeon a tool that they can do with their systems that would do that, especially at that super corporate level. Actually, Honeywell might as well, but not for most of the systems, not that I'm aware of. For those controllers that do live on the IT network, you can use IT's tools to help create that map.
Find the IP, at least find IPs.
Right. And isolate those, or paint the whole picture of the BAS VLAN.
Yeah.
That would be something that's possible. Excuse me, but that's still only going to catch automatically the controllers that are living on IT's net. If you have something like that MSTP to IP router on the back, everything below that on the MSTP network is going to be missed. When I was doing controls engineering in the field, we would use my company used either AutoCAD to literally create a drawn file that showed every one of our controllers and its pathing back to supervisory controllers, or used something like Visio to create that map. But
And then it was good until somebody changed something.
right. And maybe they even updated the map when they did it.
So there's an opportunity for some programmer who decides they want to help out us for peons in the controller world, go out, find the back controllers,
Mhm.
and have them search down to their networks underneath. That would be kind of a cool tool.
Yeah, it really would be. And I'm going to backtrack just a little bit. It's possible that Echelon has a tool like that for their networks. I don't know. And I really wonder if somebody hasn't come up with that for BACnet. And I just don't know about it. Map your entire system automatically sort of tool. Create the architecture map.
Berkeley students that we're trying
To map the whole system, or?
to. Yeah. That whole system, and then look at its efficiency.
This wasn't to look at if, well, that could be an additional function, but
It was just to find the controllers, devices that were associated with us.
kind of an architectural map.
Unless somebody puts the information in them, nobody's ever gonna know. Like what you put in a computer is gonna be in there.
Yeah.
How would you ever know where the controller's at?
Well, you could develop at least an architectural map sort of thing.
22440, whoever gets it done, wherever it starts smoking.
Well, wouldn't something like TACRAD that Jay Santos developed, it would have to do troubleshooting, sort of global.
I have no idea what that tool is, Peter.
Well, it was automated troubleshooting or problem identification. I mean, and which leads to my question: what happens with sensor failure or sensor drift, or sensor placed in the wrong location?
Mm-hmm.
Who, so much falls back on the operator
Mhm.
eventually.
You're absolutely right. So in the event of a sensor failure, hopefully your system has been set up to give you an alarm that the sensor failed. When this temperature sensor here on the wall, either it fails of natural causes or artificial causes, like, somebody running a cart into the thermostat. If you have an out-of-range temperature alarm, that alarm's going to trigger when this goes to, minus 60 degrees or 300 degrees, whichever way it goes on your system. And you're going to know, hey, I need to look at that. Wait a minute. I'm pretty sure we're not on another planet. So that temperature's out of range. And if it's that far out of range, it's broken. If for sensor drift, unless you have some sort of automated fault detection system in place that's going to look specifically for things like sensor drift, you realistically aren't going to know until you get an occupant complaint or you get another sensor that's in the same space that's reading far enough different that it's going to catch somebody's attention. If the sensor's in the wrong place, which never happens, Nobody ever puts a coffee pot under a thermostat or a laser printer or a copier. Sorry. Or on an outside wall that's not properly insulated and sealed. That's, what's that?
Direct sunlight through a window.
Direct sunlight through window, that's a good one, yeah. Those kind of things, those never happen. So why are we talking about it? No, obviously those do. So that is something that should, some of those things should be caught by the controls company at the time of install and addressed then through an RFI type process or change order type process to move the thermostat before the building gets finished. Or it's found afterwards by the building operator and oftentimes has to be a service contract type item. I don't have really great results for those answers, but that's the real answer. Say that again. You just said something.
Yeah, I did.
You did. What'd you say?
I said, that's why we do trends.
That's why we do trends.
Charlie and I were talking about if you know your discharge air temperature, you know your set point and your actual temperature, over time, you can see when there's drift.
Absolutely right. Thank you for pointing that one out. I missed it. But doing trends on things like room temperatures and set points and things, you can help start to identify those drifting situations. Most of the time I can't say most of the time. Most of the time right now we are relying on building operators to interpret the data from the trends and identify things when they start to look funny. But there are other systems in place, automated fault detection, which is starting to pick up a lot of the slack in that. Because, let's face it, building operators have a whole lot of work to do. And oftentimes you don't have anybody in a building that has enough time and knowledge to be able to sit down and dig through trends to find information like that. So it's one of those that oftentimes we start looking at the trends when we have a problem for things like that. Hopefully we look at the trends for bigger picture things more frequently, but depends on the build. Other questions on programming? All right. Let's talk about how the BAS View 3 does the programming. BAS View 3 uses a combination of 3 objects to accomplish these things. Okay? It uses an object called a runtime. Okay? This counts runtime based on conditions. Okay? So, yeah. It's just a clock that runs. That's all it is. Not going to say that's all it is. It's more than that, but we'll get into the details. It has a block called calculations. Okay? This is an easy to use, simple block for doing things like conversions, calculating CFM, combining or averaging the data from 5 room temperatures or damper positions or whatever. Okay? Easy to use, direct, simple. Okay? And then we've got programs. This is much more robust. You can do everything that a runtime does and a calculation does using a program, but it's harder to set up. Runtime and calculation are easy, very similar to what we've been doing already. Programs are much more involved, just like you'd expect them to be. Something is much more powerful, harder to use, right? By default. Runtimes. Runtimes set up a lot like we set up an alarm. Okay? We create the runtime, we set points for it to look at and conditions to be met. So things like pump status is equals on, then we accumulate runtime. If, I don't know, supply fan status and return fan status are on, then we're going to accumulate time related to maybe our air filters. Something like that. And they are set up to send messages as well. Okay, that's their primary function with runtimes, is they accumulate the runtime, they calculate it, they add it up, and when we get to 1,000 hours runtime, it's going to send a message. Hey, you've got 1,000 hours of runtime on this pump. Maybe it's time to do preventive maintenance action X. Okay, time to go grease the bearings. Check your belts. Change your filters. Whatever it happens to be. Okay? That's the intention behind runtimes. Please note, I said that's the intention. That doesn't mean it's the only way you can use it. Calculations. These set up, we already did some calculations where we were converting that number from Fahrenheit to Celsius. Calculations just take that functionality outside of the point itself so that we can do it as a separate thing. We can also access multiple points with a calculation object instead of just that one point that it's living. Okay? So if we needed to do an average, we would use a calculation. Ted?
So, other than that point about the calculations, what's the advantage of doing calculations here versus right?
You may need to maintain the integrity of that original point in its original state for some sort of display purpose. So, for example, maybe you're monitoring the speed of a variable frequency drive and you're getting hertz as the feedback from the control system. And you're using that hertz calculation or hertz data in combination with the curve for that fan and the kilowatt usage to calculate your CFM. Okay? But for the display, you want to convert it over to percentage because that's what your operators are used to seeing. Something like that. And again, the ability to access multiple data points with a single calculation. The calculation itself also acts as a virtual point. So we created that occupied point. Well, bad example. We don't have to create an additional point to put that new value into. There we go. If we were to do calculations just through a program, we would have to create an additional virtual point to dump the calculation into out of the program. Okay. Those two make sense? I mean, setups really pretty easy on these. They're quick. They are on the scale of things fairly friendly for setup. Like I said, programming, not so much. Programming, immensely more powerful. Okay? The programming for the BAS View 3 uses Python, specifically version 2.7. Yes, that is important to you. If you need to find tutorials to help you figure out how to write Python, or even if you're familiar with Python, Python's been around a long time, has gone through a whole stack of different versions, and the syntax is significantly different between 2.7 and the current generation, which is 3.x, I believe. Okay? Python is not a visual-based programming language. We're not talking blocks here. We're talking a classic scripted-based programming language. Okay? And for those of you who've been to my talks about programming in the past, I am been a huge proponent of teaching our students the visual programming, the block-based programming. Because still, within our industry, it is the predominant style of programming. Okay? I think right now about 85% of the controls companies still use block-based programming or have transitioned to using block-based programming. Okay? PLCs still largely use a visual-based programming system. It's definitely a little different than most of what we look at, but hey, it's still visual-based. Okay? You do have about 15% of the controls market uses a script-based program. Okay? This is your classic basic programming, C programming, Java programming if you're a horribly sad individual. Those types of programming. Python is that type of program. Okay? So, I think that's another very significant advantage to having this in your labs. If you only have right now controllers that do block-based programming, that's great. I think that's fantastic. But if you want to lift your students up one more level, give them one more skill set, without making them go take classes from those IT folks and getting bad habits from them, this gives you access to a way to teach them practically within what we do how to do script-based programming.
They may learn to hate visual programming.
It's possible. I learned, what's that? I first learned programming on several script-based programming systems. Okay? When I transitioned towards having to use visual programming, it was not intuitive. I had to fight with it tooth and nail to get what I needed to get done until eventually it clicked. Then it was pretty easy.
It's heartening to hear.
I will forewarn you that there is a very good chance when you first introduce script-based programming to your students, they aren't going to like it. It's not drag and drop like our visual-based programmings are. It is not that intuitive. But you will find, or they will find, if they stick with it a little bit, that they can do some really complex things much more easily.
Finer grain control.
Potentially.
Yeah.
You get people who are good at block-based programming, and you can get some really wild stuff done, surprisingly.
You can do the same thing. You can do, I'm assuming you can do virtually the same thing, because they all end up getting turned into zeros and ones anyway.
There you go. The old statement that controls are controls, doesn't matter who makes them, they still have inputs, they still have outputs, they still have logic in the middle. Russell.
Line program, that's one of the first things I teach my students.
Is it?
TC 20 controllers from Siemens.
Yep.
And they gripe and complain at the first, but once they start getting into it and stuff, they love it a lot easier, better than they do the block programming, because they set their points up first and name their points. All they got to do is type in their points.
Mm-hmm.
But on block programming, they have a hard time figuring out what type of point do I need to pull over here to do this function and stuff.
Yep.
Where in writing, you can write it out and look at it and see, okay.
And what you said right there, writing out what they need to accomplish, it is something that really, really helps with the script-based programming. Literally make them write out a sentence of what they're trying to do. And that will lead them to exactly what they need as far as that goes. But that can work with block-based as well, landing.
And I think that, like the PCL programming that he does, it's also a good foundation to get people to understand the logic behind even block programming or anything else. So it gives them a good insight, you know, when you're looking at a block and what that information might be inside that block, and writing it out, and have a better understanding.
Absolutely. I 100% agree with that. And that's something that you have to figure out for your program and your students. Which is the easier way, the more effective way to start for the goals that you are looking at and the students that you have. If you have 5 minutes to teach programming, or do you have 5 hours to teach programming? And what's your student base look like?
And obviously, I mean.
Good, Ted. What's that?
That obviously depends on your own capabilities, your own background.
Absolutely.
Right.
Yep. Jenny?
Thinking about a lesson I have that's half-baked about sequence of operation.
Mhm.
You know, we worked with that last summer. With that language, would be a good starting point to potentially teach scripted programming.
Absolutely.
In fact, what I was going to say was you could take your whole sequence of operations, put it into the program as comments before you even start programming. You can do, and then you see, and then it breaks it down into each of the sequences and what it's doing. And you can set up your start there and then put your variables, define your variables up above, and then you can go down and do each portion of the sequence, the conditions and actions right there. And then it's all in there, so it's actually, with that,
I have to see what this looks like.
Yeah.
I think I know what you mean, but I've never done this.
And Jenny, also you could use, I teach my guys how to use the block diagrams where they start with the program and they come down and have to make decisions, is where they have to go in the decision box. They write down what type of parameters, so they have to make a decision before they write the program.
Yep. And I'm going to point out that with this, with your sequence of operations, you know, either having them rewrite it in a little bit more normal form that they're used to seeing things, or translate things that they don't necessarily understand, taking that maybe to a flow diagram type thinking. Either one of those, you can go both ways with it, and you can really use those as teaching tools or self-teaching tools for your students. You know, make them go through that, and then when they get into the programming, okay, look back at your notes, look at your sequence. What did you say you needed to do here? You know, you're making a decision here. What does that sound like? Is that an if statement? Is that a thermostat block? You know, whichever way you need to go with it with what you're teaching, let that sequence. I love basing it on the sequence. As I'm teaching programming to my HVAC students, that's what we do, is we take a sequence of operations and we look at it and we go through it step by step to build our program. So absolutely, I think sequence of operation is critical to teaching building controls, HVAC, lighting controls, all of it.
Talking about the difference between the block programming and the scripting, and reminded me of my path into programming. One of the very first classes that I was required to take when I thought I was going to get a computer science degree was flow charting, which is very similar to your block programming. You write your sequence of operation in your flow chart.
You're absolutely right.
Do they call those classes logic?
Depends on the school.
Date.
logic's out of fashion.
What did you say?
Logic is out of fashion.
I think most of the time I'm used to seeing it anymore as logic and critical thinking,
Okay.
as more of an open course, less directed specifically at programming and more kind of the... I've seen that class show up in philosophy classes, or that in philosophy degrees. I've seen that also show up in more of managerial business degrees and construction management trades sort of programs as well. I know. It's amazing. It's like we use it all the time, but one of those, maybe one of those things that's kind of been converted to those soft skills that Robin mentioned before, but formalized talking about it. Okay. Mario.
If a student wanted to learn programming at 12,
Mm-hmm.
be better controls person, where would you steer them?
Oh, that's a challenging question. It is going to depend partially on their goals. If you want to learn good programming practices, how to specifically write clean, efficient programming, I would steer them to an IT department, your local IT department, hopefully, where they're probably teaching, honestly, probably teaching Python right now largely.
That's where I'm getting at, like, what, should they learn C++ or Python?
It's with the exception of saying that they should not learn an effectively dead programming language. Any programming language that they learn really is going to help them, because it's going to teach them, when they take a class on programming, they should be learning things like how to do flow diagramming to help figure out your code, how to write what's called pseudocode, which is a written out script type version of flow diagramming, but without the specific syntax of the programming language. And then they're going to learn a programming language to implement those types of thinking, and they're going to have to follow the syntax of whatever that programming language is. The tasks that they're going to accomplish in that are significantly different than what we typically do, but it's the basic skills of it, especially that ability to follow syntax and learn syntax, is what will help them when they have to learn a new programming language because their company changed partners, they changed companies, or the supplier, the manufacturer came out with a new control line that works differently than what they're used to. I would not steer them towards a web-based program either, because learning how to program web pages very different than more, like Python and C++, C#. Does anybody even teach Java anymore for intro classes? Wow. Okay. Java. That was one of the early programming languages that I learned, and most of what I learned in college was to hate Java more and more with every class. Hi, my name's Robert. I have opinions. So, but Java would still be a good language to learn, especially because some of our big companies still use Java underneath their programming systems. So, especially if a student is headed down Niagara route, the programming language that they use if you have to do something outside of a block is a can't think of a better way to say it, bastardization of Java and C. So, especially if they're going down that road, one of those two languages would be helpful, specifically, but really Python's going to be just about as good.
You want to really challenge them. That's the best one for
It's really funny because Robin and I talked about that the other day. No, okay. All right.
And I've since forgotten.
Great questions so far. Other questions before I haven't even made it past the second line on this slide? That's okay. Okay. Another thing towards Mario's question is actually this second line, or third line, whatever it is. I can't count. Python is what's called an object-oriented programming language. Okay? And realistically, almost all of the modern programming languages you're going to learn are object-oriented. All of our visual-based programming languages are object-oriented. So there will be some things like the properties of a block. Well, we're going to have properties of the objects we create in Python. We have properties of the objects we create in PLC. So that is something that we'll translate across. So the other type of programming language to avoid pointing a student at learning would be database programming. That's a whole different type of creature. And unless they're going to go into it to deal with that data analytics side, if they're going to go into data analytics, if they want to start looking at the data of buildings on that level, pointing them to a database program would be a win. But otherwise, it will not help them as much. There we go. Head to hedge that one.
Doesn't seem like Python was gonna be some rocket science programming thing, so there was, you know, like the YouTube HVAC mechanics.
Mhm.
Special people in the world. I was wondering, because you're versed very well, or anybody else that's versed in Python, if you guys could look up a couple of YouTube tutorial crash courses, guaranteed they're all over the place, but vet them so that.
And point you at some good ones.
The point is that some good ones that aren't just, you know, bleh,
Yeah.
you know, put some gas in, you know, ones like each.
There you go. So by default, I'm going to point you to a YouTube or a website and that has a YouTube channel called Adafruit.
Okay, that'd be perfect.
Adafruit. They are a group started by a young woman, absolutely brilliant lady, that they do a lot with electronics and things. And where they kind of started out was working with things like Arduino, BeagleBone, Raspberry Pi, and those all use Python. Okay? So one of the really kind of funny things you may run into with if you've got young folks coming into your program, if they went to a maybe a slightly more affluent high school, or a high school that did some programming, or they did robotics, or just had a fun science teacher who had them do projects, they actually may already know Python. Because Arduino, like I said, those three big names in the, you know, hobby controls market, IoT market, they all use Python.
Well, Arduino uses C, kind of the C variant, but
Okay.
so that's the other option that they might end up with.
See,
Gotcha.
I want the Reader's Digest version on it, I don't need
Yeah,
the
yeah.
Ayn Rand version.
Yeah, absolutely. But Adafruit has a lot of how-to videos and things like that that are very, they're short clip type videos, 5 minutes, 6 minutes, that are going to walk you through how to do things. That
They're
will,
edgy for today's students, and they're kind of edgy,
okay,
which is good.
yeah. It'll,
Millennial better, is that what you're saying?
Just take care.
yeah.
Oh, she's a social influencer. Okay, all right. I saw the picture when you came on. Edgy.
So, also, if you or your students are looking for kind of additional information on the electronics side of life, also, this is a really good resource. By the way, the name of the company was started because of the first programmer, Ada Lovelace. Okay? She was the person who wrote the programming for, oh, what's his name? Now I stopped. Babbage's. Babbage made,
Wow, I heard that name in years,
right?
years. Ever since the computer gaming store?
No.
The Babbage engine.
Babbage engine was the first computer created. No, that's why where they came up with the name for the gaming store. But Babbage made the first computer. Ada Lovelace, his assistant, was the person who was writing the programs for that computer.
That's where the name came from.
Yep, for Adafruit.
Her nickname is Lady Ada.
Yep.
I like that.
Lady character, that's good.
Another tidbit, Ada Lovelace's birthday, December 10th,
How do you know all this stuff?
because it's my birthday.
You got a little altar or something?
You,
I know. I'm
you
looking at
acknowledge
the sites
brilliant
on here, so
people
it's really cool.
in your industry. Yes.
So buy your Raspberry Pi so that
Yes.
you can support the video possibly.
Yep.
Oh, thanks. I'm not.
All right. Okay. So, one tip for writing your programs for the Raspberry, or the RasView, BAS View 3. Sorry. Obviously, we're getting close to break time. Write the program somewhere else and paste it into the BAS View. Because when you're trying to write the program, they have some hotkey functions that are set up for the BAS View. So when you try and type the letter P, a menu shows up, which is, not the most helpful thing. It's a challenge. So write your program somewhere else, paste it in.
If you're using Windows, I recommend Notepad plus plus because it has color coding go with your code.
Yes.
Makes it easy.
Notepad++ is an amazing program, and you can set it up for.
Is it tell you functionality is working so far?
Well,
Is it like a,
not exactly.
spell
It
check or
just-
something?
It helps you with syntax because if you get the command correct, it actually puts this in a specific color.
Yeah.
And you can set those colors.
And it kind of. Have you ever used any of the math editing programs where it kind of color codes like your parentheses? So when you've got an open parenthesis and a closed parenthesis in the right place, it highlights all of that section? No. Okay.
Just on Excel stuff.
That's fair.
Excel
Excel does that too. Yeah.
That's no-
So, yeah, that's the kind of thing it does.
There's another program called Wing that's specifically for Python, and it's a development.
Wing?
environment. Wing, yes. And it is, it's great. You can run it, if you set up your variables so that you can sign them, you can run the whole program and run the whole thing and debug it before you even upload it to that. So it's a very, very powerful, and it's free.
And Notepad++ is also free. And that's one of the great things when we start talking about Python. There are so many resources out there for it because it's an open source programming language, so it is free.
Any recommendations on where to download it so you don't go to one of these, I'm gonna hose you sites,
Microsoft,
that store?
well, I'm not remember if it's the store. Anyway, I usually just Google it and go for a Microsoft address.
Looks like it's gonna,
It's been a while since I've had it downloaded. I
looks
can't.
like a Russian hack site to me.
Peter,
Just a quick question. So these controllers are designed to receive Python, is that right? Can you program
Yes.
in something else or you're locked into Python?
not without blowing up everything Contemporary controls built into it.
Okay. So designed for Python.
Yes. So,
Just notepad.
yeah, regular notepad will work just fine. These others just give you some additional help functionality.
They do a lot of,
But-
with the way Wing does a lot of air tracking, the Python sets off its blocks with indentation rather than with curly brackets the way C does. And so if you get your indentation off, if like something would happen, that's something farther, that's something farther, so it just screws it all up. And then it catches that much. Does a lot of air checking.
So, can you practically tie this concept of using Python in BAS view to what we're actually doing? We're only talking about this because it's a form of customizing a specific task, right?
Correct. Yes. So this would be what I was planning for an exercise that may have been a little bit overzealous. It was lead lag programming. So that we're going to create a runtime and we're going to calculate how long we're running based off of a status point. We're going to take that into a program that when we exceed that runtime, we kick over to another pump, that kind of thing.
If we're writing to another point then, and doing that, you can still actually program in BAS View 3, you're saying, and make it a supervisory client based
Yes.
with that, okay.
Yes. Great questions. Others so far? Okay. One of the things that I find really interesting that the BAS View 3 allows you to do is it lets you set up the frequency you want a program to run. You can set it up to run every second, every minute, every hour, 3 times a day, whatever you need it to run. Okay. I will caution you, for our exercise, you're not going to crash the controller. Okay? Not with one program. In the real world, if you're using this on a system, if your students are using this, and they make 10 programs, this is a workhorse of a device, but it's doing a lot of things. So it's just like when you order with your eyes at a restaurant and you order too much, eventually you just can't eat anymore, right? Well, with the programs, you can set it up to the point where your controller is just going to fail because it can't do it anymore.
I don't think putting like a Sedona control block thing is going to even be a big deal.
No, I think
Just to have network points and have your own control strategy then.
yeah,
Get on Joe about that.
that's right. Last item, use the help files. Remember we found the little help thing? When you get into the programming, and I will show you exactly where this is, and I will show you the link that should come up really when you hit the help button, because it links you. In the first sentence it says, you really want to go here for the help that we're trying to give you. So we'll go there. Okay? But the help files are good. They give you that information like what version of Python it's running so you can go get other tutorials if you need to.